help here. Any questions before we get started?
I don't think so.
All right. So the word I got is that you've got some sort of a test if tomorrow. Is that correct?
I took it today.
Yeah. Okay. All right. Next time we'll be a little bit ahead. Does it matter what we work on tonight? Do you have anything in particular you want to do, or more stuff like the
Um, Nothing really in particular, but on our test today, we did synthetic division with polynomials. So,
right? So here's a problem from another student at your school in Algebra 2. Does this look familiar to you? Something you might have seen recently?
yeah.
All right. So let's just start with this, and then we'll kind of work around and do some other things. I do jump off camera for the lesson, more for me.
Mhm.
But if you're ready, let's go ahead and get started here. We're going to go till about 6:25, and then I'll talk about scheduling, answer any questions you have. All
Okay.
right. Okay, y-intercept, y-intercept. Any idea how to find the y-intercept of this function?
Would you plug in 0?
You do. You put exactly that. You put 0 in for x, which means you're finding f of 0. Now, before you do that, this is kind of an important thing here, is you really treat the function anywhere there's an x as if it's in parentheses, just the x though, not the other stuff. The
Mhm.
idea is that when you're substituting in, that 0 is taking the place of x in all of those positions. So it's 0 cubed minus 3 times 0 squared minus 0 plus 3, like that.
Mhm.
Now, it is often the last number, the constant, but not always. So just be careful with that. How would you write that as an ordered pair?
Um. Oh, x minus 3 and then x plus 3.
No, so
Oh,
like I'm asking you to simplify this. What is 0 cubed minus 3 times 0 squared minus 0 plus 3? What does that become?
um, it becomes 0 comma 3.
Yes. Yes, there
Minus.
you go. That's what I was asking. Good job on that. All right. So let's do this one a little bit different here, um, because you may have even already done this, and then we'll do a problem like it or something. So let's just say that x minus 1 is a factor. Okay.
Mhm.
What number goes in the box with synthetic division if this is a factor?
It would be a positive one.
Right. So you actually set it equal to 0, you solve for x, and that goes there. What
Mhm.
number do you write next for the
You'd write 1, -3, and -1, and then 3.
very good. And then you bring the 1 down.
Mhm.
Do you remember what to do from here?
And then you multiply them to get 1,
Okay, good.
and then you add them to get -2,
Okay. Then you
and
multiply
then
to get, yep, keep
negative
going.
2, and then you multiply, yeah, and you get 0.
All right. Do you remember what this is called when you're all done? That last number?
Um, no.
It's called the remainder. So if the remainder equals 0, that means that it's what's called a root or a 0 or an intercept.
Mhm,
Does that sound familiar to you?
mhm.
Okay. Now originally it was x cubed, x squared, x, and the constant.
Mhm.
With synthetic division, what is the new polynomial?
It would be 1x squared and
Okay.
then -2x and then -1x or -1.
Where are you getting that
Oh,
-1 from?
oh, up, I mean -3.
Yeah, there you go. So it becomes the constant. Good.
Okay.
And then if we bring down the factor, okay, every quadratic you know how to solve either by factoring or quadratic formula or whatever, but typically they have you factor this. Is this something you're comfortable factoring?
Um,
Two numbers that multiply to -3 but add to -2.
oh, yeah,
Kind of verbalize what you're thinking here, please.
Um, -3 and -1.
So here's one way to do it is you write all the possibilities, and there's only two. Those are the only two numbers combinations that multiply to -3.
Okay.
So one of them does add up to -2. It happens to be the first one, x minus 3, x plus 1. Okay.
Mm-hmm.
So this is what's called factored form here. Does that make sense?
Yeah.
Okay. Now there's a problem part of this that says to list all of the zeros, x-intercepts of f of x.
Yeah.
Okay. Do you remember how to use the factored form to do this? Any idea on that?
You would take the opposite of it.
So that's
So,
true, but that's you got to be careful there. It's better to set them equal to zero
okay.
because they may be more complicated in a future problem, and then you don't know what to do. But this always works.
Okay.
So could you solve each of these for x for me, please? It's what you just said, but it's being a little more formal with it.
Yeah. So you add one to both sides
Okay. So what is the
and
answer?
then positive one.
Okay. How about for the
And
middle one?
then you add a +3, so it'd be +3, and then
Okay.
you subtract the 1, so it'd be -1.
Good. Perfect. Okay. Any questions on this?
Not yet.
Okay. So these are where it crosses the x-axis.
Mhm.
Does that sound familiar to you?
Yeah.
Okay. So the way to proceed from here is to, because you're going to be asked to graph something like this, or maybe you were today. Did you have to do any graphing?
Yeah.
Okay. I call it graph as you go, or I say it that way, graph as you go. So the first thing we found was the y-intercept.
Mhm.
You would normally want to graph this first. So 0, 0, 3, a little dot there.
Mhm.
1, 3, -1. These are the intercepts. And then the last little piece here is to talk about what's called end,
Behavior.
yeah, behavior. And it's based on two things. It's based on the degree
Mhm.
and whether the leading coefficient
Is
is
positive or
positive or
negative.
negative. Yeah. So could you just
Mhm.
tell me the degree of, well, let me go find it. What was the degree of this polynomial?
It would be 3,
Why
or do
3?
because it's the highest number
Highest exponent.
exponent. Yeah.
Good. Okay. And then, oops, it's the wrong spot. 3. All right. And then the leading coefficient is the number in front of that term. Is it
So
positive
1.
or negative? It's 1. What
And
you
it's
care about, sorry.
and it's positive.
Yeah. If you care about odd, you care about the fact that it's positive. Now there's 4 graphs you need to know. We'll get to that maybe. I think we're going to do some factoring instead, work on that. But this kind of, and you don't have to make it look pretty. You just have to get it to look somewhat correct.
Mhm.
All right. Any questions, thoughts on that?
Not yet.
Okay, so let's do a little bit of factoring here. I noticed something there. When we did that. Let's see if because we don't have to have necessarily have an agenda today for our lesson. So let me put some factoring up in front of you and just see if we can talk through this thing. So let's say I gave you something like, and it'll say solve by factoring x squared plus 4n minus 12 equals 0.
Um, mm,
So you're looking for two numbers that multiply to -12 but add to +4.
okay.
And
So,
that's where you've either got to be able to guess it or you make a list with all the possibilities and one of them works.
mhm. Okay. Would it be -6 and 2?
Yes. So tell me what to write inside parentheses now.
You would write x on the outside. Oh, oh yeah, x minus 6, and then x plus 2.
Good. You seem a little uncertain, but yes, exactly what you said there. You put those two numbers inside what's called the binomial bi, meaning two terms.
Mhm.
Okay, now we're solving. We're solving. So we're not done. What do we do next? How do we get how do we get the values for x? So what did we do? What did we do up here?
We set it to 0.
Set each factor equal to 0.
Mhm. So it'd be x minus 6 equals 0, and x plus 2 equals 0. So it'd be add a 6 on both sides, and it'd
Okay,
be x equals 6, and then x equals negative 2.
very good. Okay, you ready to try one on your own?
Sure.
The interactive part of the lesson. All right, so I want you to solve by factoring. I'm here to answer questions. I can scroll up if I need to, but see if you can figure this out, please.
Okay. Okay, it's 6 and 4. Hmm. And they have to add to negative 4. Um, I'm not sure.
Okay. So there's a mistake in here. I apologize. That should be negative. Nope, that does not work. Sorry, did I really give you one that doesn't work? I'm so sorry.
It's
That's
okay.
just terrible. That's just terrible. Let's do this. This one does work. Um I grabbed this from the internet. I just go out and find problems and don't look to see if they solve. This one does though. So give this a try, please.
Would it be negative 8 and 4?
So are you giving me your final, what are you giving me? Are you giving me your final answers? Because what I'm looking for, like, here's what I would hope you would write down. This next line, then set them equal to 0, then this. Okay.
Oh, okay.
So as much of that as you can do would be
So it'd be in parentheses x minus 8, and then x plus 4, and then
good.
you'd set each of them equal to 0.
Yes. So what are the final answers here?
X equals positive 8 and x equals negative 4.
Very good. Okay. That went really well. Let's try one more here before we move on to something else. Let's say it's x squared minus x equals 56. What is different about this problem compared to the others?
There's no coefficient in the middle to.
Okay, now there's a coefficient. I'll even put one there.
Mhm.
Something else that's different. Let's
Okay,
go back and look. What is this equal to?
0,
What was this one equal to?
0.
So we want this to equal 0. So how do you undo or get rid of this 56?
You subtract it from that
Yeah,
side.
exactly. All right. So And you're right. There is no coefficient because it's not written, so you can write one if you need to. Now
Mm-hmm.
it looks like a problem that you know how to solve. So this one
Mm-hmm.
does work. I have checked it. Give this a try, please.
Okay. Would it be x minus 1 or x minus 56?
So you're looking for two numbers that multiply to minus 56 but add to -1. So what you gave me, yes, or if you gave me those two, those definitely multiply to minus 56, but do they add to -1?
No.
No. And other thing here, I am not anti-calculator, so if you feel like that would help you, please grab one or, whatever. I
Okay.
don't recommend using your phone if you've got like a TI-83 or something you might be using in the classroom. That'd be better than the phone.
Mhm.
But
So x minus 8 and x plus 7.
keep going.
Okay, and then you set them each to 0. And
Yes.
then you
Give me
would add the 8, so it's x equals positive 8 and x equals negative 7.
good. Okay, let's try one more here. Then we'll try a different type of factoring. All right, go ahead and solve this for us, please.
Okay, would it be x minus 8 and x plus 5?
So here's one way to answer your question is we're going to FOIL this. So you get x squared plus 5x minus 8x minus 40. Is that the same as the original?
No.
Okay, so there's a mistake. So remember, you're trying to get to 40 and it has to add to minus 13. So -8 and 5, they don't even multiply to 40. They multiply to -40.
Oh, okay. So
So they're either both negative or they're both positive. So do
so they
either of
both
these add,
be
do I, go ahead?
so they'd both be negative?
Yes.
Okay.
There's actually three types of factoring of this case. So I'm just sort of scrambling them up, but um, it's not uncommon to miss these, not have them all done. Let's try one more here. Let's try one more. See if you can two numbers that multiply to 6 but add to -5.
I know they would be 6 and 1, and they'd both have to be positive or negative.
Okay, so -1 and -6, they don't add to -5. So what's another possibility for 6? What's two other numbers that multiply to 6?
Oh, 2 and 3.
Okay, but we want it to be -5.
So they both be negative.
Yes.
And then x equals +2 and x equals +3.
Very good. Let's try, this will be probably our last problem here. Let's go, x squared minus 6x plus 8 equals 0. Try solving that for us, please.
Okay. It would be -4 and -2.
Is that your final answer?
I think so.
So remember, we're solving. Like, what you told me is actually the two numbers that multiply to 8 add to -6. Like, it's correct, but that's not the final answer. Like, if I was just grading
Okay.
what's there, or if it were like multiple choice, a multiple choice would have the wrong answers there as well. So you're
Okay.
actually like, we got to carry it all the way through. So x is 4
And
and
x
x is 2.
is 2. Okay.
All right. Hey, good job. We're gonna stop right there for
Okay.
today, but hang